For our second example, we're talking about a baseball. A baseball is being shot upward from the surface of the earth. So we have, you know, the surface of the earth. I'll draw it in green for grass. And then you have a baseball, and it gets shot straight up in the air, and then it comes back down. Okay, so that is what, that's like the picture that we're dealing with. It has initial velocity of 160 feet per second. So that means whoever is like shooting it up or throwing it up, that's how fast it's going away from their hand. Here is a position function. It has a couple holes. When you see V sub 0 or S sub 0, those are constant values. Those are numbers that we need to figure out what they are. So we're going to have to plug numbers in there, and then that after we have numbers in with those highlighted areas, then we'll have a complete position equation. So I'm going to talk about those. So V sub 0 stands for the velocity. That's why it's V. Sub 0 means at time 0. So it's the initial velocity. I say initial because it's the one at time 0. So we were told what the initial velocity is. It is 160 feet. So in this, feet per second. So in this case, V sub 0 or V naught is 160. S sub 0 is your initial position. So it is at time equals 0. Where is your ball? What is the height? What is the location? And here it says it's shot upward from the surface of the earth. So in this case, S sub 0 is 0 because the ball is starting on the earth. If you were like standing on top of a ladder and throwing the ball up, your height would be taller because you'd be off the ground more. So, but this one says it's being shot from the surface of the earth. So your initial position is 0. So when I go and rewrite this equation, S of t equals negative 16 t squared. V naught is 160, so I'll write 160 t plus S naught, that is 0, so I'm not going to write it. So this is my final position equation, and I'll use it to answer all of the questions.